This question is from topic relative velocity. In this question, it says that a river which is 80 meter wide and the water flows in that river at a speed of 2 meter per second between the parallel banks. Point to be noted that they did not mention any direction of the flow, so we will have to assume the direction by ourselves. Now in this river, a man wants to row his boat straight across the river, which means he wants to land directly opposite his starting point. In the last line of this question, it says that the man can row his boat in still water with a speed of 3 meter per second. Before solving this math, let's see what data we have in our hand to solve this problem. Here, we know that the speed of the water is 2 meter per second, but we don't know the direction of this flow yet. So let's write the velocity of the water Vw is equal to 2 meter per second. And next, we have the velocity of the boat in still water is 3 meter per second, which means velocity of the boat relative to water is 3 meter per second. So let's write velocity of the boat relative to water is equal to 3 meter per second. We also know that the river is 80 meter wide. Using all of this information, let's try to draw a diagram. If we can draw the diagram correctly, then after that it should be a very simple and straightforward problem to solve. Let me draw the two parallel banks first. So here are the two parallel lines where the distance between those parallel lines is 80 meters. So let me mark this thing or write this thing. Okay, now let me mark the starting position and ending position of the boat. Let's say the starting position is A and the ending position is B, and the boat must come directly from A to B, where AB is perpendicular to the banks. Now let's say the direction of the water flows from left to right. So therefore the man must steer his boat somewhere in this direction. Let's say this direction is AC. So and now let's put the values. So Vw is equals to 2 and V relative to water is 3 meter per second, and AB is the resultant velocity. We might need to find that. Now let's say that the line AC creates an angle theta with the bank, and therefore since the banks are parallel, the angle ACB is also theta. Since AB is parallel to CB, therefore the angle B is a right angle triangle. As a 90 degree. Therefore the triangle ABC is a right angle triangle. Now using the cosine ratio, we can write that cos theta is equals to 2 over 3. By making theta as subject, we can write cos inverse 2 over 3, and using the calculator we can calculate the value of the theta is as 48.2 degree. Therefore we can say that the direction, let me write, so the direction of the boat is 48.2 degree angle with the bank upstream. So we have completed the first part of this question. Let's move on to the last part of this question. Let me scroll down the page a bit so that we can read the question here. Okay, now Here we need to find the time for the boat to cross the river directly from A to B. Let me sketch the triangle roughly. The triangle ACB. So let me put the symbols ACB. AC was 3, CB was 2. We have to find AB is what? That is VB is what? Since it's a right angle triangle, using Pythagoras theorem, we can write VB is equal to square root of 3 squared minus 2 squared, which is equal to square root of 9 minus 4. Let me write 4, which is equals to square root of 5. So we got the speed in the direction of AB. Now the time will be equals to the distance of AB, that is 80 meter, divided by the speed, which is square root of 5, which is equal to 16 times square root 5. So let me write 16 times square root 5, which is equal to 35.8 second. So we have completed the solution of this problem. Now let's move on to the next question.